I almost forgot. Okay, so we have that. All right, what are we doing? We are going through. We have this. We have this. We have this. C, D, E, F. Let's do this. All right. So what we're going to do is we're going to do first 2 digits. We're going to do 2 digits. So I have my number. I have my abacus. Hello, everybody. Hello. Welcome, welcome, welcome. So what we're doing is we are looking at my abacus. This abacus is a counting tool. So what we're going to do is we're going to look at our tens. This is the tens, and then this is the ones. So when I look, I have my tens and I have my ones. This is 15. I have a 1 and a 5. When I look, where's my abacus? Where's my... So we have place values. We have our tens and our ones, and that's what we're doing. So then that's 15 when I go 15. So 15 looks like that. That's what 15 looks like. 1, 5. I have my 1 in the tens and 1 in the fives. Right? Cool. So what's next? We have this. We have this number. This number is my, I'm going to do this. This number I'm going to do is my tens. This is my tens. This is my ones, right? I have 1, 2 in my tens. So I have 1, 2. And then this one is 4. 1, 2, 3, 4. Hello, everybody. Hello. Welcome, welcome. So what are we doing? This is number 24. This is 24. Okay. And to see 24, thank you so much for the likes. What we're doing is we're reading the abacus. And I need to find 24. 24 looks like that. So 24 is a 2 and a 4. And then I have to move my book. So I go here. So this book is a abacus book. This is a maze. There's a bunch of mazes in this book. And so what we're doing is we're learning how to read the abacus. So I have my tens, and then I have my ones. So if I look, I have my tens, 5, 6, 7, and then I have my ones, 1, 2. When I look, I have 72. That's what this number is, 72. So I have to find 72. There is 72. 72. That's what 72 looks like. Now it takes me to this box over here. This box is what? I have my tens and I have my ones. So when I show on my abacus, I have my tens and I have my ones. My number is 16. Hello, hello everybody, welcome. So I have 16 on my abacus. So when I look, I have to find 16 on my book. In my book, I have to find 16. And then I have, thank you so much for the likes. What we're doing is we're doing a puzzle, and we're looking at how to read the abacus. Let me know if you have any questions. Oh, very interesting. All right, so I have my tens. This is my tens, and then this is my ones. What number do we think this is? If I have my tens, and then this is my ones, I have 1, 2, 3, and then I have 1, 2, 3, 4. What number do we, oh yeah. Hey, Angela, thank you. Thank you, Angela. Yes, it is 34. Welcome. I'm very happy I'm not the only one in the room. So we have our number. We have our tens. We have 5, 6, 7, 8. So 8 looks like this. 5, 6, 7, 8, and then we do it again in my ones. So I have 5, 6, 7, 8. So my number is, what number do we think this is? We have 88. When I look for 88, thank you, Angela. Thank you, meow, ugh. Thank you so much. Thank you so much. Now I don't feel so alone. All right, so we have our tens. What we're doing is we're reading the abacus. We have our tens. This is 5, and then here's my tens. So my tens look like this, and my ones look like this. What number do we think this is? Oh, all right. I've never learned to use it. I'm so glad I stumbled across this. Oh, yeah, I'm getting it now. Oh, good, Angela, good. Meow, good. Right? Makes sense. Easy. Simple to use, easy to understand. Yes. Yay, Jeffers! You got your new abacus today. I wrapped it up too, right? No, it's not 35. It is 79. 5, 6, 7, and then 5, 6, 7, 8, 9. We have 79. That's what 79 looks like. Oh, that means Jeffers can actually, right? Jeffers can actually do this at the same time. Ha, Sam. Sam, cheater. It is not 35. You guys are hilarious. 79. 79. So that's what 79. We lag. All right. So what are we doing? We have our tens, and then there's ones. But notice in the ones, there are none of the beads, right? Thank you, Jeffers. It is 50. How do I know it's 50? Because the top bead will always be 5. The top bead is always 5, so this is now 50. 5, 0. This is my tens, this is my ones. So it takes me to 50, and I go all the way over here. So then I have this number, my tens and my ones. What number? Oh, I can't see that. What number do we think this is? So my tens, this is my tens, and then this is my ones. What number? 37. Thank you, Meow. Almost, Abby. Thank you, Jeffers. Thank you, Amy. Yes. Hey, Melinda, 37. Thank you. Yes, 37. So, Abby, 7 just looks like this without any beads. So this would be 7. But right now we have 37. And so we have this number right here. What number do we see? We have our tens and we have our ones. We have our tens and we have our ones. 27. Thank you. Thank you. Thank you. Thank you, Jeffers, Meow, Abby, Melinda, Angela. We have 27. We're going to go over here. And then what do we have? We have, oh my God, if they taught me this elementary, I would have been unstoppable, right? We have, yes, our tens and our ones. Wait till we start doing adding and subtracting and multiplication, Meow. We're going to do adding and subtracting pretty soon. But I want to make sure we all understand how to read the abacus. 87. Yes, we're going to do 87. I have 5, 6, 7, 8. 5, 6, 7. Yep. Thank you. Thank you. And our last number is, what number do we think this is? Oh my God, I've always wanted. Division is fun too. Division is fun. Oh yeah. I got my little automation going. Whoo! Multiplication, division is so fun. We have 50, we have 9, we have 5, and we have 9. My final answer is 59. Meow. Yes, okay, I was going to say. So remember, 40 looks like this, and 19 looks like that. Great. Thank you, everybody, for joining. Thank you so much for helping me complete my abacus and my maze and making sure that it's correct. I actually found a couple of typos on my other one, and I'll get that corrected. But yeah, that's the one thing, right? Getting a can't find an editor to help me edit this because they don't know what they're doing. The abacus. What does that mean? Well, I'm sorry. Before I continue, if you guys are looking for this, this is available at not my shop because it's all sold out. Thank you everybody for buying this. It is available here. My name is Lynette. Thank you so much. I could do it. I'm sure you could. Yes, I know you could. But but I don't want to take you away from everything. My name is Lynette. I've been teaching abacus for 20 years, and I have a bunch of abacus abacus workbooks, worksheets, online classes, all in abacus. What we're doing is we're going to learn how to do adding, subtracting, multiplication, and division. Thank you everybody for joining. Let me know if you have any questions. But this is available not in my shop because I've sold out. Thank you everybody for joining. But if you're looking for it, it's right here, and it is available over there. My name is Lynette. Thank you for joining. Okay, so what are we going to do now? What we're going to do now is we're going to understand how to move the abacus. What we're going to do is we're going to learn. Okay, so if you notice, this is a standard size abacus. Because of the standard size abacus, you'll notice that I have these beads. These beads are pointed, and because they're pointed, you should be able to use your edges of your fingers to move the beads. Does that make sense? You don't need to be aggressive, right? We're not being aggressive. What we're going to be doing is we're going to be gentle and we're going to be happy. We're going to be happy to do abacus. And so what we're going to do is we're going to understand that when I add 7, I'm doing this. I'm touching the edges of the beads to add the 7. When I open it up and then I make a 9, I pinch it all together, I'm going to be using the edges of the beads. So the abacus is very easy to move, so you want to make sure you use your left hand to stabilize, because why? It's easy to bump, right? If it's easy to bump, your answer is going to get wrong. And then the other thing is you don't want to flick. You don't want to flick.
And flick. Oh, you flick too hard, damn it.
You don't want to flick. What you want to do is you want to move with intention. So if I have 5 and I want to add 2, right now I'm adding 2. So I have 5, 5, 5, 5, 5, 5, 5, and this is 7. 5, 6, 7. This is 7. So now we all know how to use the abacus. We all know how it all works. The abacus, this is the beginning part, right? We're going to do preschool abacus. No, it doesn't matter. We all need to do this. We all need to understand how to move the abacus. And thank you guys for joining. What's the decimal? Yes, thank you. So if you noticed, we have this dot. This is my dot. And in this dot is like a Pokemon.
Okay, Charizard, I choose you!
So when I look, I can choose this one, and then I have my 1s, my 10s, my 100s, my 1000s, my 10,000s. However, if I
Pokemon, I choose you!
If I choose this one, then I would move everything over, and I'd be my 1s, my 10s, and then there's no more room for 100s, and there's no more room for 1000s. It would only be 10. It would only be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. 20, 30, 40, and then 50, 60, 70, 80, 90, and then I have no more room for 100. That's why I go back to...
Okay, Charizard, I choose you!
So because I have this one as my 1s, you'll notice that my decimal sits between the 1s and the 10ths. And so right here is my decimal. And then I have my 10ths, and then I have my 100ths. Oh, that's not going to work. All right, that's fine. Okay, cool? So, yes, that's what the decimal is on the second column. That's what that means. But this is not a decimal. This is actually just an indicator. This is a label. That's what it is. That's just a label. All right, so the next thing we're going to do is we're going to understand that in Abacus world, we're going to understand the add-in. This is the add-in, right? We all understand the process to get there, right? We don't want to do is we don't want to focus on the result. We want to focus on the process. Why? Because it's all about life. It's the journey, right? Marry the process and divorce the result. The idea is we want to know if we have enough beats. So the question here is, I want to add the 5. I add the 5. I want to add the 1. When I add the 1, my final answer is 6. I can do it again with the 2. So when I look at the 2, I have 6. I have 6. And then do I have enough to add the 2?
Yes, we can.
Yes, I have enough to add the 2. 1, 2. I'm going to have enough to add the 2. My final answer is 8. And so when I look at this, now in mainstream math, we talk about dots. You could do dots, or you can do it on the abacus, and we do 5, right? And we plus the 3. Now we know we can supertize. When we supertize, that means that I can just look at it and know that this is 8. 5, 6, 7, 8. Or you can do the mainstream way and just count everything. 1, 2, 3, 4, 5, 6, 7, 8. You could do that. But I like to use the abacus because I could see it easily. And then that's the other thing is the it'd be more difficult when there's more dots, because you can only do so many dots. So that's thing about the dots and the abacus, how abacus is a little bit more beneficial. And then 4, when you notice, when we add the 4, we want to go to the horizontal bar. When we subtract, we want to go away from the horizontal bar. So when we add, we go 2. So this is adding of the 2. We want to take away, we minus the 1. It's the same thing with the 4. We add the 4, we go to the horizontal bar. We subtract, we go away from the horizontal bar. Why don't they teach, meow? I don't think they've ever taught this. I didn't learn this when I was a kid. I had to memorize. And so when I started learning how to do the abacus, I was like, this is the greatest thing next to sliced bread. Yeah. My kids know it. I have 3 boys. My kids know how to use the abacus only because I forced them. So then I want to add the 3, I'm going to take away the 1. But notice it's very easy to show how to minus, right? And you're going to start seeing that there's a number pattern, right? So we add the 1, and then we take away the 1. We add 6, right? We add 6, we take away the 6. We add the 5, we take away the 5. Notice it's just the number pattern. You'll see the patterns. So when we add 7, we add the 7 like this. When we take away the 7, we do that. They didn't think so, but they do now. Many centuries ago, but now. Many centuries ago in Mesopotamia, right? Many centuries ago. You know, it's very common in India, like East India. It's very common in Asia, like Singapore, Malaysia. And it's starting to trickle into like Africa, because I got a few African, I have a few African abacus teachers following me. So it's everywhere except America. And you know what? I realize it's because nobody connects mainstream math to abacus. Abacus is really math, and abacus is the gateway to complex math. So abacus is actually there's a whole set of abacus vocabulary that never is understood by mainstream math. So what I'm going to be doing is I'm going to start telling you, like, isolating the variable, add in. We never in the abacus, never in abacus world do we talk about the add in. We always talk about just add the 2. So, but it made sense when I said focus on the add in. Made sense when I say what we want to do is we want to focus on the process. But in abacus world, we don't say any of that. But in mainstream, we always say, how do you make an 8? We want to do 5 plus 3. No. We don't want to be result oriented. What we want to be is we want to be process oriented. So we want to know, can we do it? So if I have the 3, can I take away the 2?
Yes, we can.
Yes, we can. We can take away the 2, and that's all I do. And that's it. That's it. So it goes again and again, right? And it just compounds the information. I want to add the 4. I want to take away the 4. I add the 4, take away the 4, and that's it. Okay, what are we doing? We're going to add the 5. Again, the add in, right? The thing is, how do you do negative numbers? You don't do negative numbers, because that's the question, right? Like, how do you take away more than you have? You can't really go in debt. You can't really show to go in debt. I mean, you could, but that's, yeah. But like physically, can you do it? No. Because what the abacus does is it tracks our numbers. That's what it does. It helps us track the numbers. There is no way to show negative unless you keep it in your head. So, but anyways. All right. So what are we doing? We're doing 6. When we add the 6, I want to add the 1. When I add the 1, can I add the 6?
Yes, we can.
Yes, to add the 6, all I have to do is plus the 1, plus the top, plus the 1 top and the 1 bottom. 5, 6, and you bring it together. You pinch it. And then when I want to minus, I just push it away. So I can add the 6 or take away the 6. And this is something that we're going to really understand, right? And so it's the same thing with the 7. Okay, we're done. We know the basics. It's just like putting on your jacket and taking it off. Anybody remember that one? Put on your jacket, right? Take off your jacket. So what we're going to do, we're going to take off our jacket, and then we're going to put on our jacket. So if you notice, I added the 7, I take away the 7. I add the 8, I take away the 8. And so what we're doing is we're learning the fundamentals. This is really easy, Lynette. This is like too easy. I understand, but we need to know, right? We need to know the fundamentals before we can start going into bigger numbers. So here, when I want to add the 1 and I want to add 8, do I have enough? Yes, I have enough. And then all I got to do is take away the 8 if I want to minus. So now it leads me to this question. Guess what? Because we now know how to move the beads, I can show you how to do a 3-digit question. Here is a 3-digit question. We have 2, we have 8, we have 3. Wow, that's a lot. Well, no, because now what we're going to do is we're going to go by every number. You could, if you wanted to, what mainstream does is find the friendly numbers. I don't know about you, but I'm a little rude. I'm like, you know what? I don't need to be friendly. What we do here is the question is can we do it? Can I add the 5? If I'm here, can I add the 5? Yes, I can add the 5. Then I add the 1. Yes, I can add the 1. If I have a 1 here, yes, I can add another 1. So my final answer is what? Oh, that's not my final answer. My final answer is 7. Everybody in the chat, if you can let me know, what is my final answer? What did we just do? We just did a 3-digit number. And it's easy. And it gets better. Yeah? Was that the answer? Do we see that? 794. We can do it the other way. Oh, thank you. Hey, thank you, Ali Bree. So we could do it the other way. If I have 283, I want to add the 1. That's it. I got to add the 1. Can I add another 1? Yes, I'll add another 1. And then can I add the 5? Yes, I'm going to add the 5. That's it. Yes, right, Angela? Yes, just like Emmett in Lego Builder. He's like, I could see everything, right? So now you see it. It's easy to see because now we're not figuring out what this means. We see it visually on the abacus. The abacus helps us understand the numbers that's there. That's why the questions really make sense. The questions is, how does it teach to add without the abacus? How does it teach? Well, you start imagining how you start imagining it in your mind. Just like typing. How do you type without seeing the keys? Ha 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 ha. How do you type without seeing the keys? You just type. You just know the words. You know how everything goes. It's the same thing with the abacus. You start doing enough times, you can see it in your mind. You do it enough times, you see the number pattern enough times. If I do this, I know I'm taking away 1. I know if I do this, I'm taking away 2. I know if I'm taking away 3, right? You start seeing it. That's how they do it that's how the kids do it in their mind. It's kind of like binary. You know, people say that. I don't know binary. So I guess I don't know how to do binary. I'm trying to figure that out, but I can't do binary. I guess so it's like on off, but then we're doing 2. But then we're doing 3. I don't know. That's something. I've always wanted to learn how this works in almost 40. Okay, so what did we just do? Thank you so much, Heather, for the heart me. So what are we going to do? We just did is the simple thing, right? We just did a simple adding and subtracting. That's it. We're done. No, we're not done. Because why? The next thing we're going to do is we're going to understand what happens when there's not enough beads. What do you mean? What kind of crazy is that? Here is the concept. Oh, no, that's the wrong one. Here's the concept. Oh, so before I forget, this is a abacus. This abacus is made out of plastic, and it's very easy to move. And I do have it in my shop. If I can find my shop. There we go. There we go. If you're looking for it, I do have it there. You can find it everywhere else, or you can find it here. It's up to you. But just so you know, it's very easy to move, and it's like a little rattle. Because it's like a little rattle, right? What you want to do is you want to make sure that you want to use your left hand to stabilize it. Thank you, Heather, for the TikTok something. Thank you so much. Thank you. Thank you. I appreciate the gift. I appreciate the gift, Heather. Thank you so much. So what are we going to do? Now the question is if I have 2 and I want to add another 2, that's fine. That's really easy. Okay, that's fine. But now what's going to happen is what happens is when we don't have enough beads. So I have this one question. This is the question I like to go to, right? I wish my daughter didn't go to... Oh, Are there abacus that has more than 9 digits in a slot? Yes, there is. Here is a Chinese abacus. So what do we do? Heather, just so you know, I'm also available I also come on live in the morning as well. I don't know if summer has set in yet, but I do come on about 8 o'clock Pacific Standard Time, 8 in the morning, just so you know. So Logan, we do have the Chinese abacus. This is the Japanese abacus. This is the more modern one. This is still being used, but now it's all the old Chinese people. I don't know anybody else who uses this, but it counts the same, right? We do 1, 2, 3, 4, 5. Because we have 5, we're gonna trade that in to make this 5. The top beat is always 5. And what happens last week of school? And sometimes I'm at work. Most times I'm at work. Oh, yeah, but you're not at work now, right, Angela? Yeah, this is our last week. Yeah, I'll be here. I'm going to be here. I'll be here until I'm not. No. Right. Right, Angela? Okay, so this is 5. And then we do 6, 7, 8, 9, 10. Guess what? We're going to do another trade, right? To the tens place. We add 1 bead to the tens place. Now we have 10. It's the same thing on the Japanese abacus. We have 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then we have 10. So we have a 10, 1 and a 0, 1 and 0. So Logan, did that answer your question? That's it. That's the only one that I know. There's another one. It's called a Russian abacus, and a Russian abacus has 10 beads across. I don't have an example of that. Oh, thank you so much, Heather. Thank you so much. Please tap and share and send your heart me. Thank you so much. Thank you so much for the finger heart. Okay, what we're going to do is we're going to understand this. This is what we're going to understand. Plus 3. We're going to add 3 on our abacus. And you know what? I'm going to use some money. Money, 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 money. Because why? It makes sense when I use money. What do you mean it makes sense? Well, here is my money. I have 3 on the abacus. I have 3 pennies. These are 1 cent each. Because they're 1 cent each, I need to add the 4. When I add the 4, right, I don't have any more beads to add the 4. Sure, true it does. Right? We don't have enough beads to add the 4. But guess what? I have a nickel. I have 5 cents. But that is too much. Having a nickel is too much. So what am I going to do? I have to take away the 1. I can show you again on my abacus. I can add the 5 and I can take away the 1. And my final answer is 7. And that's what it is. That's all it is. So what are we going to do? We're going to do it again. Here is 4. If I have 4 on my abacus, I want to add another 4. Guess what? I don't have enough bead to add the 4. I'm not going to memorize 8 plus 8. What I'm going to do is I'm going to understand this concept. I have a 5. I have change. I have more than enough, but it's too much. So I'm expecting change back. I'm just going to take away the 1. So I can show you on my abacus. I'm going to add the 5 and I'm going to take away the 1. And my final answer is 8. How does that work for everybody? Is that okay for everybody? How is that doing? So what does that mean? We can do it again. So now what we're doing is we have this concept, but we can do it again. We can repeat it, right? And we can process and understand and really get to know and become ingrained. So we have 2 on the abacus. I want to add the 4. There's not enough. So I have 2 pennies on the abacus. I have 2 pennies. I want to add the 4, but there's not enough. So I'm going to give you my 5 cents, but that's too much. I need to take away the 1. So I can show you on my abacus. I have the 1. I add the 5 and I take away the 1. So my final answer is 6. That's it. Cool? How are you doing? Ooh, if it's going pretty fast, right? If we go pretty fast, we might be able to get into some multiplication and division. Okay, anybody have any questions? We're going to do it again. We can do it again with the 3. Why? Why do we do this? Because we're teaching this at school. We're teaching this concept. This is the concept we're teaching in school, but that's all they teach them. They don't teach them anything else. They don't teach them to utilize it. What we're doing is we're doing some...
You need modification! Modify! Modify!
So we're doing some modification. What does that mean? Well, we're taking this concept. We have 3. We're going to add the 3. What's another way to add the 3? The partner of 3 is 2. So what we can do is we can modify it. Now, this is where we get into some big people words, right? This mainstream words. If I want to add the 3, I can do what? If I need to add the 3, I have my add-in. My add-in, I isolate my variable. When I isolate my variable, I'm going to substitute this concept into 3. So what I'm going to do is I'm going to take, if I need to add the 3, that's what I did. I need to add the 3, guess what? I'm going to have my 5, but that's too much. I have my 5, that's too much. I need to take away the 1. Take away the 2. So I'm going to take away the 2. When I show you on my abacus, I have 3. And then I have to add another 3. That's too much, right? Adding the 5 is too much. I need to take away the 2. So my final answer is now 6. Does that make sense? How are we doing? Right?
Welcome to the real world.
And that's it. That's what we're doing. And it's a little bit like algebra, but we actually know our variable. So here is another thing, right? You could say x is equal to 5 minus 2, and we substitute it in, right? So, I don't know, there's a whole bunch of like substitutions that you can do. But what we do here is very, very similar to algebra, but not algebra, just so you know. So here's another example. So this is 4. I have 4 on my abacus. If I have 4 on my abacus, 1, 2, 3, 4, right? I have 4 on my abacus. I want to add the 3. I need to add the 3. Guess what? I don't have enough to add the 3. I'm going to give you my 5 cents, but that's too much. I need to take away the 2. So here I'm showing you the directions. I'm going to add the 5, take away the 2. So my answer is 7. So I bring it down like that, and that's 7. Does that make sense? So what did we just do? We understood this concept, and this is what making of the 5 is. How are we doing? So let's do another big question. What? What big question? This big question. 26, already double digit? Yeah. Because now we know how to do, we know how to add the 5. So if I have 26, right, we're going to take every column. Every column we're going to understand. So this column has 2, right? We want to add the 3, but that's too much. So guess what? I can give you my 5 cents, but 5 cents is too much. I will take away the 2. So I'm going to show you on my abacus. I add the 5 and I take away the 2. Then here, can I add the 2? Yes, I'm going to add the 2. So my final answer is 58. 58. Right? So now what did I show you? I demonstrated how it's easy to scale our concept that is very basic, a very elementary. Did that make sense? We can do it again. Here's a bigger number. So we have 13,578. And then what are we going to do? We're going to add 24,311. What? That's a lot of numbers, yes. But if we take it number by number, column by column, I want to add the 2. I'm adding the 2. I want to add the 4. Can I add the 4? No, I can't. What do? I have my 5. Guess what? That's too much. So I'm going to take away the 1 because we're doing the 4. So I'm going to add the 5, take away the 4. And then we add the 3. Can I add the 3? Yes, I'm going to add the 3. Can I add the 1? Yes, I'm going to add the 1. And again, can I add the 1? Yes, I'm going to add the 1. So my final answer is 37,889. Right?
This is the way.
This is the way.
This is the way.
How are we doing? I don't know if I'm lagging. Thank you so much, everybody, for the hearts. Thank you so much for the hearts. So how's it going? Anybody have any questions? Seems a little quiet, but I'll keep going. I'll keep going. So we could do it again with a 2. When we're looking at the 2, again, we're going to check to see if we have enough first. We always need to check to see if we have enough. So if I have 1 and then I have the 2, is there enough? Yes, there is enough to add the 2, so I'm going to add the 2. So my final answer is 3. Now here I have 2. Can I add another 2? Yes, I can add another 2, so my final answer is what? 4. 1, 2, 3, 4. This is where we start using the formulas. Lady J, holy cow, man. I haven't seen you for a bit. How is it going? It's been a while. Lady J. I had like a whole bunch of letters coming by. All right. So thank you so much for the support. All right. So we have 3. When I have 3, I'm doing well. I'm excited. I'm starting to feel that there's a little bit of an uptick with my abacus stuff. And it's really, really quite interesting. I'm just hoping that it will keep going, you know. I'm hoping it doesn't plateau. But I think that there's enough people that don't understand abacus that I still have a lot to teach. Yeah. And then there's a great plan of I've already published a few books. I'm on my 11th book now. No, 12th book now. And in the works, after my 13th book will be Introduction to Abacus for Adults. And then I'm like, holy cow. I think I'm going to start. I have to make an online class for adults. And I'm like, what? So that's the plan. I'm going to do an online class, self-paced videos for adults. And I'm like, wow, really? Okay, Angela. But yeah, it'll be self-paced, so then that means that the videos are going to be all pre-recorded. Oh my God, Jenna, really? Really? See, that's so strange. I honestly thought that I was only going to be teaching kids, but because you guys were like mentioning, and then I know Jeffers too, and then he's really interested in the I know I know Melinda's also interested in the multiplication and division. So there's a whole path, and I'm going to be pretty busy. My goal is going to be, yeah. So I'm just going to keep making. Hello, Jojo. Welcome, welcome, welcome. So I'm going to keep going with the question. So many of us need to go back to foundations. Really? Okay. See, that's the funny thing. Like, it's interesting to me because I've been in it for so long. Like, I've been teaching abacus for 20 years, but I've only been teaching to kids. And I just now started getting into TikTok, and I'm like, oh my gosh, I can't believe it. Okay, but the answer to the equation, please. I'm learning. So here, I want to add the 2. Oh, I have 3, right? I have 3. But we know this, Sarah. If I have 3, what? That's too much. I might add the 5 cents. That's too much. What am I going to do? I need to add the 2. To add the 2, I put in the 5. 5 is too much, so I need to take away the 3. That's what it is. Because these are the pairs. Well, these are the pairs. So I can show you again on my abacus. I want to add the 5, and I take away the 3. Teach us adults, and I understand, but not all. I'm sorry. What? Teach us adults. Yes, I understand, but not all. Oh, I understand some, but not all. Yeah. Yeah, it's really just interesting. We can do it again, Sarah. We can do it again. So we do it again. I want to add 4. I have 4 on my abacus, right? I want to add 2, but I don't have any more beads. I have nothing left over to add. So what I'm going to do, I'm going to give you my 5 cents. Because I'm going to give you my 5 cents, it's too much. I need change back. I need to take away the 3. So my final answer is 6. 5, 6. And I can show you on my abacus. If I have the 5 and then I take away the 3, my final answer is 6. Right?
Welcome to the real world.
Yeah. And that's what it is. It's understanding that there's a different way of looking. So I'm hoping that people that are in my room can please.
Now, open your mind to me, please. Open your mind.
So again, target adults going back to school as non-traditional students and somehow using a hub. And how using Abacus. Oh, that makes a lot of sense, Jana. Thank you. That makes so much sense. Thank you. Yeah, not a problem. But we're not done. Why? Because we only did 2. We did 4, right? We did 3. This is 2. Now we have 1 more. We have 1. But the funny thing about 1 is there's not a lot of questions for the 1. It's only this one right here. So it goes back to, is there enough? Right? The question is always, can I do it? Yes, I can. I want to add 1 and I add another 1. That's not a problem. If I have 2 and I add another 1, again, not a problem. I have 3, I want to add a 1. Can I do it? Yes, I can do it. Not a problem. Now I have 4. I want to add the 1. Now is where I have to understand I need to add the 5, take away the 4, right? Same thing. If I have 4 and I want to add the 1, to give you my 5 cents, but I need change back, so I'm going to take away 4. And that's what I did. So what I just did was understand how to make a 5. We in Abacus world need this information, right? In mainstream world, I'm not sure why they're doing this. I don't know why we're doing this, but in Abacus world, we need this. Trigonometry was troublesome when I did it. So was memorizing doubles and all the other stupid strategies that mainstream math is telling us to do. Doubles plus 1, doubles minus 1, and I don't know what else they were talking about. And then like all the number bonds. That's like a pain. So what we're going to do is we're going to understand that, because we understand that these are pairs, we can go to the next problem, right? What's the next situation? The next situation is if we know how to add, we know how to subtract. So if we know how to add, we will know how to subtract. I don't have that one. I have it, but it's not, I'm out of stock. So if we know how to add, we will know how to subtract. What does that mean? Our next one is, we're going to understand this concept is minus the 5. We're going to take away the 5. Is the book, what? Is the book edible? Jake. No, wait. Were you a business professor? No, I wasn't. I'm sorry. Question, why do you start in the 3rd roll? Yes, thank you, Jojo. The reason why is because I have this dot right here, right? Because I have a dot. This is my ones label. This is an indicator. So this is my label. So if I wanted to, I could choose...
Pokemon, I choose you!
If I choose this one over here, what am I going to do? Then everything will be here. Then it would be 1s, 10s, but now I have no more room for hundreds and I have no more room for thousands. But then when I choose...
Okay, Charizard, I choose you!
If I choose this one, now I have a lot more columns to have my digits. So my ones, my tens, my hundreds, my thousand, my 10,000. So if I look at it, I could do 1,000. I could do 1,001, 1,002. Yeah. Yeah, that's a very good question. And so it happens again with my 13 column one. With my 13 column one, it's the same thing, right? I have my ones. I could choose this one to be my ones. And if you notice, every section is a comma. So I have my ones, my thousands, my millions, my billions, and my trillions, right? If you want, you could choose this one, and then you'd only have up to million. But it doesn't matter as long as you know how big your number is. So the bigger the number, right, the more columns you'll need, right? Because what? Size matters. All right. So that was that. And what happens? So we're doing that. And then what we're going to do is we're going to understand how to minus. We know how to add. We will know how to subtract. So now I'm just going to show you how to subtract. It's easy because the concept is the same. You'll notice that it's a number pattern that we're looking at. So here it is, right? We want to take away the 4. Notice when I take away the 4, it's minus the 4, minus 1 is equal to minus the 5. This is not this is kind of a negative, but this is kind of a negative that we needed to understand. Why? Because the question is 8 minus 4. We're taking 8 on my abacus, right? And I want to take away the 4. Guess what? I'm going to utilize the 5. I need to minus the 5 plus the 1. See how that there's a number pattern? There's a plus the 5 minus the 1. When I want to add the 4, we just do the opposite of the operation. Does that make sense? We know how to add, we know how to subtract. So we know how to subtract. So if I do the same thing, if I have 16, right? I have 16 on my abacus. 16 on my abacus, I want to take away 4. I don't have any more beads to take away 4. I only have 1, 2, 3. No, I only have 1 to take away. So what do? I need to utilize my 5. I minus the 5 plus the 1, and I go up together at the same time. Does that make sense? So, what did we just do? What we did is we understood and we isolated our variable. Remember, our variable was the 4, the minus 4. So when we're looking, we want to do minus the 4, right? We're isolating the variable is equal to minus the 5 plus the 1. Right? Looks very similar to x is equal to minus the 5 plus the 1. This right here actually tells me what to do. I want to take away the 5 and add the 1. That is why we add the symbols in front. So we know what we're trying to do. Here's an example question. When I have a 5 and I want to take away the 4, guess what? I have a 5, take away the 4. I'm going to substitute minus the 5 plus the 1. Minus the 5 plus the 1. And my final answer is 1. Yep. Make sense? And so when we're looking at it, right, what we did is we isolate the variable. We made the 4 by itself. And that's what we did here. It's the same thing, but just in a different situation, right? Same thing with different situation. We have 15 on the abacus. 1, 5. I want to take away the 4. So what do? Minus the 5 is equal to what? Minus the 4 is what? Minus the 5 plus the 1. Minus the 5 plus the 1. My final answer is now what number? What number is my final answer? Thank you, Lady J. So this one was tic-tac-toe. We can do some tic-tac-toe. Oh, nice math. I have this problem I can't figure out. Can you walk me through it? Hey, thank you, Cool Fox. What is your problem, Marcos? Is it abacus related? That's the other question. If it's arithmetic related, I can help you. But if it's anything else, I cannot help you. I don't know calculus. I'm just letting you know. That's above my pay grade. I do have people that do ask me specific arithmetic questions, and I can't answer them. Any arithmetic questions that's a positive answer. It's percentages and decimals. Yeah, I could still do it on the abacus. Let's see if you break my brain. What about the decimals and the percentages? Are we adding or subtracting or multiplying and dividing? So here is the question that I have. So if I have the 2, 1, 2, I add the 6. I'm adding the 6, and I take away the 4. If I take away the 4, what am I going to do? I'm going to minus the 5 plus the 1. We could do decimals and percentages, but you kind of need to know you're adding and subtracting. That's just so you know, right? Because it's more intermediate. What I'm doing right now is I'm doing the basics. I'm doing the fundamentals. Once we understand the fundamentals, then we can go fast, right? You got to go slow to go fast, right? So we can't skip steps. So you could tell me what it is, but I'll have to marinate on it if you want. Not a problem. And then you know what? If you give me the question, maybe what I could do if I don't answer it, I can give you a post on it, and I'll put your name. Hey, Cody! Yeah, yesterday Carter broke my brain, and I'm like, oh my god, I've been on too long. That when my brain breaks is when I've been on too long, and I'm like, I can't think anymore. All right, so Marcos, let me know what your question is, and let me see if I can do it. And then the question is here: if I do -3, the question is what, 7? And then minus the 3. When I want to take away the 3, I don't have enough beads. Guess what? This is what I can do. Minus the 3 is equal to minus the 5 plus the 2. Minus the 5 plus the 2. So my final answer is 4. Does that make sense? Oh my God, my mom has the same name. Oh, hey. Hey, George, how's your day been? It's been really good. It's been really good. Yesterday I published a book. Today I'm almost done with another book, and I think I'll be able to publish it tomorrow. I'm actually quite excited. And then I'll be on my 12th book, and then I'll have some time to work on the adult book. Thank you, George. Thank you. I appreciate that. It's just, keep trucking away. So if anybody's interested in the books, I do have it available in my TikTok shop. But the ones that are out of stock is available in the other place, and I don't have it with me right now. But yes. What is your Abacus going to be? It's going to be Abacus. It's going to be all the beginning parts of the Abacus, and then moves everybody forward. So we're going to start with the fundamentals, which is adding and subtracting with the formulas, and then that will be one book. And then the next book would be two-step equations, and it'll be a bunch of two-step equations with some activity stuff, right? So I was thinking about some coloring by number, some mazes, maybe some anagrams that they have to try to figure out, and some other activities, right? That's Abacus focused, but it's fun for adults, right? And I'm gonna keep the same print, and this will translate nicely to kids that are older as well. So it's going to be kind of a catch-22, not a catch-22. It's going to be kind of like an everything. And then after the second book, so it's going to be a series. So then after the second book, there's going to be a multiplication. And then after multiplication, I don't know how big that's going to be. I haven't really quite figured that part out yet. But then after my multiplication, there will be division. Oh, it's division problem that's divided by 25. Forgot to mention it's about money. No, that's fine. Okay, so 25 by 5. That's it? You're going to 20. Okay. So the problem is to divide by 25. And we're going to do this. You want to do this on the Abacus? We could do it on the Abacus. Whoa! What? Is that what we're going to do? We're going to do it on the Abacus? Oh, so if anybody's interested, I have some books that's available here. My name is Lynette. I've been teaching Abacus for 20 years. And now I'm teaching on TikTok. Okay, so let's see. Okay. But yeah, I do have my books available on TikTok as well. Let's see. But Marcos, do you know Abacus? I don't remember. 263.75. Money doesn't matter, and decimals doesn't matter because it's not part of the divisor. Right? Because it's not part of the divisor, we don't have to worry about. And so what we're going to do is we're going to compare. Thank you, Tanya. I love Abacus. So, Marcos, does that make sense? Or I create a post on this. I can create a post on this as well. And then I don't confuse people that are here. How are we doing? Do we want to go forward? Anybody? Bueller? Because what it is just really this. No, I don't say I struggle with these types of problems. I want to do adding. Okay. Yes to the division and subtracting. Okay. Okay, Marcos, I do long division on the abacus. And so I can send you a post on this. But see, the thing is we do have to start with understanding how to read the abacus. So let me go back to the subtraction, and thank you, Abby, for letting me know. And Jamie. Hello, Jamie. Welcome back. So on the abacus, we can do it. I'm fine with that. Okay. But it will be a while till you get to understanding how to do multiplication as well. So the first thing now what we're going to do is we're going to understand, we're going to understand how to take away the 3, right? There's like steps to get to division. And we're not quite there yet. So if I have 16, I have 16, I have 1, and I have 6. I'm going to take away the 3. When I take away the 3, guess what? I don't have enough. If I don't have enough, what do? I have to minus the 3 is equal to minus the 5 plus the 2. Where you know this, right? Because what did we do? We did...
You need modification! Modify! Modify!
So we did modification. Remember what the formula was? The formula was 3. 3 minus 2, minus 3 minus 2 is equal to minus 5. Remember what we did is we isolated the variable. We're isolating the minus the 3. When we minus the 3, right, we want to minus the 5 plus the 2. That's what we're going to do. So when we minus the 5 plus the 2, I just given you directions on how to use the abacus. I want to minus the 5 and I'm going to plus the 2. So my final answer is 13. And then I have activities that goes with it. After that, we can do what? We can do this one, right? So the reason why, no, okay, so here's another thing. The reason why we don't want to say, oh, this cancels out is because we want to show you, I wanted to show you how to move the beats. So if I have the 1 and I want to add the 4, right? I have the 1 and I want to add the 4. To add the 4 is plus the 5 minus the 1. So then what's going to happen is I want to take away the 4. To take away the 4, I'm going to minus the 5 plus the 1. So it's easy for us to be like, oh, they cancel out each other. But the reason why it's here like this is so you could see the movement of the numbers. That's the reason why it is what it is. Right? So, I mean, obviously there's a way to like shortcut all of this, right? I could say like, oh, 5 plus 2 is 7, then take away 4. You could do it, right? It's not a problem. This is like really simple. But the idea to go through one number at a time is to see the way the numbers work. So if I have the 5, I'm going to minus the 4. When I take away the 4, I'm going to minus the 5 plus the 1. And then I'm going to plus the 2. And I just add the 2. So does that make sense? I mean, I know, but then this book was meant for kids. This book was meant for ages 4 to 9, and they were going through it. But even for your child, I wouldn't tell them to shortcut it because I want them to see the numbers, right? The idea is just to keep going to see the numbers. Like I could do this, right? Okay, George, thank you so much. Have a nice day. Thank you, George, for the confetti and the little crown. I didn't see that. Thank you so much. I appreciate it. Have a nice night. And I'll see you on my next live. So yeah, so I mean, it's easy to do, right? Like I know that this is 5, I can just take away 1. That's not a problem, but that's not the issue. What we're trying to do is we're trying to show the way the beads move. Because if you don't practice now, that when we get to the bigger numbers, you're going to be a little lost. Because when you start getting more numbers, you're not going to be able to recognize that if I have the 6 and I want to add the 1 or take away the 1, all I got to do is do this, right? And then I want to take away the 4. Take away the 4 is minus the 1, minus the 5 plus the 1. And that's it. Okay, so we're going to add the 2. We're going to take away the 2. When we take away the 2, again, what are we going to do? We have 6 and we have to minus the 2. Notice there's not enough beads to minus the 2. I only have this one number. I only have this. So to take away the 2, what I can do? I can minus the 5, but that's too much. I took away too much. I need to actually put back 3. So I'm going to put back 3. My final answer is 4. So 6 minus 2, my answer is 4. And then we're going to keep going. So here, I didn't do this, but we can do it. So if I have 25, right? If I have 25 on my abacus, let me do 25. 25! Can you explain how these things work? Hi, Derry. 25. So if I have 25 as my odd, right? Notice I'm going to take away the 2. When I take away the 2, the top bead Top is 5, yes. So I'm going to minus the 2 is equal to what? Minus the 5 plus the 3. This is something that we're going to have to know. This is something that we're going to have to memorize. So when we're looking, I have 20, I have 5, right? This is 25. Just as Abby mentioned, the top beat is 5. So when I look, this is 2. This is 1, 2. But it's in the tens place. When I have my place value, ones, tens, hundreds, thousands, 10,000. That's what that means. So every column is a place value. I want to minus the 2. To minus the 2, I don't have enough. I have no beads to take away, but I have this 5. Guess what? I can do change, right? Take away the 5, add the 3. So if I go and I take away the 5, that's too much. Taking away the 2 is too much. So I need to add the 3. So my final answer is 23. 23. 20, 1, 2. This is 2 and a 0, right? 23, 1, 2, 3. This is 23. So that's what we did. So what we're trying to do is understand how to minus the 2. So I can do it again if I had 6. 6 minus 2. Guess what? I don't have enough beads. How do you know, Lynette? Because I'm a mind reader. No, because I've been looking at this too often. So what I'm going to do, minus the 2. Take away the 2. There's not enough beads to take away the 2. What do I do? Minus the 2 is equal to minus the 5 plus the 3. We're going to utilize this 5. We're going to take it away, but that's too much. So what are we going to do? We're going to add the 3. So my final answer is 4. Yeah? Yeah. No, it takes a little bit, Derry. We're like in the middle, right? So, just kind of hang out a little bit and you'll start to get to understand it. Because what happens? This is 4. We can do 14. This is 24. This is 34. This is 44. And then we have 54. But what I'm doing right now is I'm trying to explain what happens when we don't have enough beats to add. So here, if I have 4, I want to add the 5, we can do it. We just need to move the beat down. When we add, we want to go to the horizontal bar. When we subtract, we want to go away from the horizontal bar. So we know how to add, we know how to subtract. Very easy. It's the same. It's just the opposite. So what we're doing is we're understanding if there's not enough beads, we're going to utilize the 5. The 5 is one of the core concepts in Abacus. It's also a concept in mainstream math, but nobody has yet to tell me why we learn it. But in Abacus, it's very critical because we have this 5 right here. Because we have this 5, it's very easy to go higher than 4. So if I want to add the 5, I want to add 4. So I have 4 plus 4. All I got to do is plus the 5 minus the 1. So here in this example, if I have 4 on my Abacus, here is 4 pennies, right, on my Abacus. And I want to add another 4, but guess what? I don't have any more loose beads. So I can give you my 5 cents. But what? 5 cents, I'm going to give you my 5 cents, but that's too much. I need to take away the 1. So what's going to happen is I can show you on my Abacus. I can add the 5 and then I can take away the 1. So my final answer is 8. Hey, Darwin. Perfectly fine. Perfectly fine. I'm still here. We're all still around. We're still hanging out. We're still hanging out looking at Abacus. Right, Derry? Did that make sense? So now, because we know how to add the 4, right, plus the 4 minus the 1, right, we know how to subtract. We can minus the 5, add the 1. How is my voice? My voice is fine. Thank you. It's not the voice that's my problem. It's my cough. And when the air gets dry or if the wind is going, that's when I get a little tickle in my throat. But I do appreciate. Thank you so much for the concern. Yesterday was a little late. Right. So how are we doing, Derry? Did that make sense? Oh, see you. I looked away 1 minute. Where did we get the money from? Okay. So let's start over. We have 4. The question is 4. I want to add another 4. I have 4 on my Abacus. 1, 2, 3, 4. If I have 4 and I want to add another 4, I'm not going to memorize 4 plus 4. What I'm going to do is I have 5 cents. The 5 cents is too much. I need to have change back. So 4, if I add the 5, I need to take away the 1. That's my change back. I can show you on my Abacus. I add the 5 and I take away the 1. My final answer is 8. So what I was showing was if you know how to add, you will know how to subtract. And that's what we just did. That's it. So then the question is what? Now we can go into carrying on, carrying over, borrowing. We're going to borrow. What does that mean? Well, that's the next one, right? What we're going to do is we're going to understand. We know how to add the 5. We know how to subtract the 5. What's next? The next thing we're going to do is we're going to add the 10. LMN. Who was it? It was LMN. No, there was a somebody said their name was Noel. Yeah, that was a really funny one. Okay, anyways. So, I'm lost but I'm learning. Okay, good. Let's take a little review. And then we're going to go into the plus 10s. What is a plus 10? Thank you, Derry, for the follow. So what are we doing? We're going to add the 10. Oh, I'm going to do this. So for those of you that want to know, I have this book that we're going to look at. Come on, this one? Yeah. Okay. So let's do a little review for LMN. Okay. So we have 1, 2, 3, 4. This is 4. And then we have 5, 6, 7, 8, 9, and then we have 10. That's it. How do I know? Every column is a place value. So when we look, we have our ones, our tens, our hundreds, our thousands, our 10,000s. So we have 10, 20, 30, 40, 50, 60, 70, 80, 90, and then we have 100. 101. And then we can keep counting. So then this is 101. If we look, this is 1,000. 1000, right? And then this is 10,000. 10000. That's it. That's how we read the abacus. And then now what we're going to do is we're going to understand how to make a 10. Making a 10 is a very common thing that we teach in mainstream school. In school, we're teaching the kids how to make a 10. We have to know that these are partners. 7 and 3, 4 and 6, 1 and 9, 2 and 8, 5 and 5. So let's do 5 and 5 because that seems to be the easiest. Why? I don't know, because it's pretty cool. So what we're going to do is we're going to understand 5. 5 plus 5 is equal to 10. What does that mean? Remember what 10 is. 10 is a 1 and a 0. So what we're going to do is you're going to utilize this concept. This concept we need to, right? We're going to power it up. When we power it up. I don't even know if I said that right. Power it up. We have this concept, right? 5 plus 5 is equal to 10. What we're going to do is we're going to isolate the variable. We're going to isolate the 5 and says plus the 10 minus the 5. What does that mean? This is isolating the variable. And then what we're going to do is we're going to substitute this information. How does that work here? Well, if we look, we have 9. Because we have 9 on my abacus, I want to add the 5. But I don't have enough beads to add the 5. So let me show you. If I have 9 on my abacus, here's my money, right? I have 9 on my abacus. 1, 5, 6, 7, 8, 9. I have 9 on my abacus. I need to add the 5, but guess what? I don't have enough bead. Well, I have a 10 cents. So I'm going to give you my 10 cents, but that's too much. What do I need to do? I need to remove the 5. I need change back. So now I have this concept, but it looks very familiar, doesn't it? We've done this before. All I got to do is add my 10, but take away the 5. And now my final answer is 14. So the answer to this question is 14. Did that make sense? So we did it again. Now what are we going to do? We're going to do it again. Why? Because this is the fundamental. Understanding how to move the beads, but also understanding the formulas, right? So if I have 7 on my abacus, I'm going to have 7 on my abacus, right? 5, 6, 7. Nope, that's 7. There. 7. If I have 7 on my abacus, I want to add the 5. When I add the 5, I don't have enough beads. I have no more beads to add the 5. But guess what? I have 10 cents. If I have 10 cents, I'm going to give you my 10 cents, but that's too much. I need change back. I need 5 back. So my final answer is 12. 10, 11, 12. I can show you on my abacus. I'm going to add the 10, and I'm going to take away the 2. My final answer is 15. Okay, Derry, have a good night. I'll pop in next time. Okay, yeah. See you in my next live. Hey, Cheyenne? What about the other numbers other than 5? Oh, good, Abby. Thank you so much. So, yeah, let's do it. Right? Now, if you notice, what? If you notice, what is the pair of 8? How do you make a 10 with an 8? Do you know how to make a 10 with an 8? Hey, Jana, see you next time. See you next time, Jana. Thank you so much for dropping by. 2. Right, exactly. So what's going to happen? Let me show you. So if I have 4 on my abacus, I have 4 on my abacus, right? I have 4 on my abacus. Guess what? I want to add 8. But because I add 8, I have a nickel. I have a dime. I have 10 cents. 10 cents is too much. Guess what? I'm going to take away 2. Same thing. I add the 10 and I take away the 2. That's it. Same thing. We do the 9. Let's do 9. I want to add 8. Add the 8. 9. Add the 8. When I add the 8, I'm going to give you 10 cents. But then 10 is too much. I need to take away the 2. So I'm going to get back my change, which is 2. So my final answer is 17. I can show you on my abacus. I add the 10 and I take away the 2. Right? We can do it again with the 7. What? Yeah. Take away the 2, right? So that's the formula. The formula, that's one of the formulas. So here we could do it again with the 7. 7, it's the same concept but different numbers, the different pair. What's the pair? How do you make a 7? What's the 7 to make a 10? The pair of 7 is 3. So if I have 9, I have 9 on my abacus, right? 5, 6, 7, 8, 9. I want to do 7. I have 10 cents. Thank you, Abby. I have 10 cents, but 10 cents is too much. I need change back. I need 3 to come back. So I can show you on my abacus. I have 9, and then I want to add 7. To add the 7, I plus the 10 minus the 3. That's it. So my final answer is 16. 1, right? 6. Thank you, Abby. Makes sense, right? We have all of these pairs. We can do any of these pairs. Not a problem. We can do 9. Are you ready to do 9? Makes sense, right? So easy. Abacus makes everything so easy. So easy. So we do 2. We do 2. Let's do 2. Guess what? I want to add the 9. If I have 2, I want to add the 9. I don't have any more beads to add 9. I only have 7, right? I need to add. So what do? I have 10 cents. Let me give you my 10 cents. But that's too much. What do? I take away the 1. Hey, Mila. Oh, have a great night. Yeah, you too. Thanks for stopping by. I appreciate that. Right? So what do? I can show you on my abacus. I add the 10, but that's too much. I need to take away 1. No, not add the 5. Because what? How do you make 10 with a 5? 10 plus 1, 1 plus 9 is equal to 10. Because we're adding a 9. Right? It's all about how to make a 10. So if I want to add the 9, how do I make a 10? Did that make sense, Abby? 10 plus 20, 10 and 21. Muted my hand. What? Plus the 10 and then 21. Plus the 10, 21. Nope, I don't know. Plus the 10 minus the 1. So that's the thing. Know the pairs. So when we want to add the 9, right, we have 3. Let's do another one. We have 3 on the abacus. If I have 3 on my abacus, I want to add 9. But guess what? I don't have enough to add the 9. So if I don't have the 9, right, I get 10 cents. I have 10 cents. So I'm going to give you my 10 cents, and I need to take away 1. So what am I left with? I'm left with 12. I can show you on my abacus. I have 10 cents, and I take away the 1. My final answer is 21. Oh, I see what you're saying. No, 12. My answer is 12. Plus the 9 minus the, plus the 10 minus the 1. Muted. Nyan. Right? So what are we doing? We're going to understand that when I want to, right, we have 3. If you look, this is what I'm doing. I'm plussing the 10 minus the 1. So if you can memorize this, right, this is the formula. plus the 10 minus the 1 to add the 9. Did that make sense? So when we look, we can do it again. We have 4. If we have 4 on my abacus, right? We have 4 on my abacus. Let me show you with my 4. I want to add the 9. To add the 9 is what? I can give you my 10 cents. So I'm going to give you my 10 cents, but that's too much. I need change back. I need 1 back. So I'm going to take away 1. I can take away 1 from the abacus. So my final answer is 13. Use the coins, make it easier. Yeah, using the coins when we add is easier. I haven't figured out how to use the coins for subtracting. I think it's still a little difficult. But yeah, thank you, Jojo, for the reassurance. Hey, Ollie. Ollie's antics. 12. Yes, 12. And I'm now on 13. Yeah? Right? Make sense now? Yeah. Yeah, I haven't figured out how to make it the other way. That the subtraction has always been a little bit. So, oh hey. Not a problem, Jeffers, not a problem. We were just about to finish up with some minusing adding the 10. We were doing the 10s. And then we were going to do some more adding. We were going to do my FYP Patricia. I don't want to do math. Isaac. Don't be math blocked. Can we add with hundreds? Yeah. Let's do that. Add with hundreds. I have to. I gotta change this out. So yeah. Now what we're doing is we're going to start going to understand. We understand how to do adding of the 10 because we know how to add the 10. We know how to add the 5. What we're going to do now is we're going to start Tetrising our way through our information. So that means what? We're going to understand that we understand how to add the 5. We know how to add the 10. Now that's the big thing. That's the secret. If you know how to do those two, then it'll be easy to add and subtract anything under the sun. And that's what we're going to do right now. If I can find my mouse. What are we doing? Let's do this one? Okay. So here's a question. We have, this one's easy. This one is 17 plus 82, right? Easy. Why is it easy? Because we have enough. So if I have 17, right? 1, 7. And then we're going to have 82. Sometimes we can, it doesn't matter which way you go. You can go left to right or right to left. It doesn't matter. So we're going to add the 2. Is there enough? Yes, there is enough to add the 2. So I just add the 2. Then what do? I'm going to add the 8. I'm adding the 8. So my answer is, thank you, Jeffers, 99. Of the 2 and the 9 and the 1 nickel, 4 pennies and the 2 pennies away. Yes. So if I have 2, I used my abacus. I was like, wait a minute. Right? Right, Jeffers? Like, it's easy to see. When you see it, it's easy to see the numbers. When we have 1 and we have 7, it's easy to see that you have the 2 and the 8 available. It's so crazy. Okay, sorry, Jojo. The 9, so if I have 9, oh, I see. If I have 9 and I want to subtract the 2, that's what I'm doing. But what? If I have 9 and I want to add the 2, right? If I have 9 and I want to add the 2, what do? I can't minus the 5. I can't add the 5. What's another way? Plus 2 is equal to what? Plus the 10 minus the 8. Right? Oh, good, LMN. Good. So I want to plus the 10 and then take away the 8. Take away the 8. So my final answer is 11. So you have 1 nickel, 4 pennies, and you take 2. But see, that's what it is, right? So look, you said, so if you do it the other way, 9 minus 2. Can I do it? Can I do it? Yes. There's enough beads to take away 2. I don't need to use any formulas. I just take away the 2, just like that. That's it, right? That's the difference. The difference is Abacus can tell you whether you need to do more or not. It is up to you. Does that make sense? Yeah, right?
Welcome to the real world.
So, that was simple. We can do it again with the 2, but let me do this one. Okay, this is easy. This is easy. How is it easy? Because it's what? 41 plus 51, right? We're doing adding. So I have 4 on my abacus. I have 41 on my abacus. I want to add 51. I want to add the 5. I want to add the 1. Easy. Why? Because I have enough. I don't need to worry about it. I'm going to add the 1, right? I'm going to add the 5 and add the 1. That's it. My answer is 92. Add the 1. Yep. Thank you, Abby. Right? So that's the answer, 92. We can do it again. Let's do another one. I got to find another one. That was too easy. Let's try this one. Simple. Okay, let's try this. This is when we start doing some carrying over, right? Here. So the next one, Jeffers, are you ready? 39 plus 34. We know this. We don't need to do friendly numbers, but we know how to do this. We know 39, 39. Now, what are we going to do first? Are we going to do 4 or 3? What are we going to do first? Hey, Jihad. Yes, 92. Thank you. 92. Thank you so much. I was talking too fast. Do the 3 first. We know how to do the 3. No, it's just a small thing. No, I appreciate it. Thank you so much. I appreciate it. Because I just keep going. My brain's not broken yet. So we're going to do the 3 first. Abby, add the 3. How do we add the 3? We know how to add the 3. How do we add the 3? 3. Remember how to add the 3? We have 3. 1, 2, 3. I'm going to add the 5, but that's too much. I need to take away the 2. Add the 5, take away the 2. Right? We're here. Okay, now what? We're going to add the 4. Guess what? We have 9. We have 9. We add the 4. There's too much. So what do? I got 10 cents. So what is it? Plus the 4 is what? Plus the 4 is equal to plus the 5, plus the 10 minus 6. So we're going to plus the 10, and we're going to take away the 6. So my final answer is what? 73. 73. Plus the, add the 10 minus the 6. This is hard. It's not hard, not so pro. It's not hard. You take one number at a time. Take one number at a time. Let's do it the other way. Let's do 39, right? Plus 34, right? We'll do the 4 first. Let's do the 4 first. 39. When we add the 4, what are we doing? Let's add the 4 first. How do you add the 4? Remember how to add the 4. Plus the 4 is equal to plus the 10 minus 6. Just as Jeffer said. Plus the 10 minus the 6. Take away the 6. And then we'll add the 3. To add the 3, we have 4. But guess what? There's not enough to add the 4. I have no more loose beads. So I need to add the 5. But that's too much. I need to take away the 2. So I'm going to add the 5, take away the 2. Plus 3 is equal to plus the 5 minus 2. One step at a time, right? Yeah, you add. One step at a time. You one number at a time, and then you goes all the way through. Oh my gosh, my answer is 73. 73, right? So this is not a 2-step. This is just double digits. Oh, that's better. Yeah. Yeah, no, it's still the same. We're just going through it, right? We're just walking through. Let's do this one. No, let's do this one. We have, what do we have? We do 68 plus 43. What's first? 4 or 3? What do you want to do first? I can see 3 digits. It's a struggle focusing on the abacus without doing it in my head. It is a struggle. It's a different way of thinking, I'll tell you that. I'm very good at math, but careful for things, but not the colorful things. Okay, we'll do the 4 first. Okay. So let's do it this way. So we have 68, right? We do the 4 first. Can we add the 4? No. Can we add the 5? No, we cannot add the 5. What is another way to add the 4? Plus the 4 is what? Plus 4 is equal to plus the 10 minus 6. So plus the 10 minus the 6. Yes, thank you, Abby, right? So we're done with the 4, right? Now we're at the 3. We want to add the 3. Can I add the 5? No. So what are we going to do? Plus the 3 is what? Plus the 10 minus 7. Plus the 10, take away the 7. You know, Jeffers, what really helps me is saying it out loud. Yeah, minus the 7. It really helps me when I say it out loud. So my final answer is 111. Yeah. Yeah. But I've come to a point now that I do it so often that it doesn't hurt my brain as much. Thank you. This is fun. Oh, good. Oh, good. Math in the middle of the night. Yeah. It's just a matter of practice at this point. Yeah, that's what it is. That's really what it is. Because you got the basics, you got the fundamentals, and now it's just trying to figure out, like, yeah, because it's a struggle to, like, see the numbers. Right? We could do another one. We could do this one. 69 and 97. It's 1 a.m. I want to order an abacus. Oh, you guys are fun. Oh, learning a lot. Thank you so much. I think I spelled it wrong. Oh, yeah. Abacus. So we can do it again. So we have, I'm going to go back to the colorful one because I like the colorful one. So we have 60, we have 9. When we do it, right, we're going to do which one? The 9 or the 7 first? What do you want to do first? And we break it down. We break it down for each number. Which one do you want to do first? Because I know we'll do the 9 first. Okay, so 9. Can I add the 9? When we add the 9, what are we going to do? Can we add the 9? Plus the 9 is what? No. Hey, lovely, welcome back. Wow, it's been a while. Plus the 9 is what? Minus the 4. No, we're adding the 9. So when we add the 9, what are we doing? Plus the 10 minus the 1. Plus the 10, 1, 0, 1, 0, 1, 0. And then we want to minus the 1. We take away the 1. And then we're doing the 7. 7 is equal to what? Is there enough? To 100. Oh, yeah, Jojo, I did the 6. Wait, Jojo, hold on. I want to add the 7. If I want to add the 7 to the 9, I want to plus the 10 minus the 3. There you go. Plus the 10 minus the 3. And my final answer is 166. All right, Jojo. You have one is it 10 beads across? Jojo. Right? Do you always start? No, I start from the top. Hold on. I put the top bead first on my abacus. 1, 2, 3, 4, 5, 6, 7, 8, 10. Jojo, do you have this one, right? We can get the bigger numbers. It's crazy interesting when we get the bigger numbers. Yeah. Jojo, you have something like this? It looks like your device. It looks like this, or it looks like 10 beads across, like this. Oh, interesting. So you have 10 columns, right? So then that means you have 10 columns. So instead of a 13 column, you have 10 columns. That does 100. Oh, okay. Does that make sense? Abby. Yeah. So when we're looking, right, we start from the top. We always start from the top. 69. Right? And then I'm adding from the bottom. We're adding the... You know what, though? We don't go... Like, if I had more numbers, we go line by line. So if I was to add it all together, we go line by line. We don't do all. So like if we had 48, 73, 24, if we did something like that, right? If we did something like this, it would go line by line. So we do 48, right? And then what? We have 74, add the 7, I'm sorry, 73, add the 7, add the 3, add the 7. Plus 7 is what? Plus 7 is equal to plus the 10 minus 3. So we're going to plus the 7 minus the 3, plus the 10 minus the 3, and then we add the 3. Add the 3. We don't have enough, so we know to plus the 3 is equal to plus the 10 minus the 7, plus the 10 minus the 7. So we're done with that. Now we go here. We want to add 24. Add 2, add 4, add 2, add 4. Is there enough to add the 4? No. What do? Plus 4 is equal to plus the 5 minus 1. So plus the 5 minus the 1. So my final answer is 145. 145. It doesn't matter if they're lined up. It doesn't matter. Because we go line by line. We go line and then line and then line. Which is interesting. So I know in mainstream math you have to line it up, because the way in the mainstream math you do it this way. You do this and then you do this. But in Abacus we do it line by line. We do a running total. Yeah. Okay, let's do another one. Are we ready for another one? Now what we're going to do, let's see if I can find it. Mixed numbers is what I'm going to talk about. Mixed numbers. What is a mixed number? A mixed number is when we actually have to take this number and we have to add it to something else. So the first number we're going to do is understand what. This is a very common one. Not common, but you'll see. You'll see. So Jeffers knows this one, right? I like it your way. It's the Abacus way. It's not. I didn't invent it. I didn't invent this. This is just a common thing. Like anybody who does Abacus will understand. But thank you. I appreciate that. So the first thing we're gonna do is we're gonna understand what 8 plus 5, right? So Jeffers, do you remember this one? And then we can do the opposite, or not the opposite. We're gonna do the inverse. 5 plus 8. This is very different. Does the abacus only work for adding and subtracting? No, it also works for multiplication and division. It also does multiplication. So we also do multiplication and division. It just depends on how fast the class goes. And then if you want some of the abacus books, I do have it in my TikTok shop, or it's over here. Hi, my name is Lynette. I've been teaching Abacus for 20 years, and now I'm teaching on TikTok. Welcome, everybody. So, what are we going to do? Now, what we're going to do is we're going to really understand how it's different. Again, we want to focus on our add-in. Our add-in is the 5. We know how to add the 5. We know this. So, what do? We have 8. We want to add the 5. Is there enough to add the 5? Yes, there is. Plus the 5 is equal to what? Plus the 10 minus 5. So I'm going to plus the 10 minus the 5. That's easy. Not a problem. We've done this before. So my final answer is 13. Well, isn't it the same here? You know. Why? Because this is what makes it different. Now we're going to see. We have 5, right? We add the 5, and then we're going to add the 8. When we add the 8, what are we going to do? Is there enough? Remember how to add the 8? We had to add the 8 is equal to what? Plus the 10 minus 2. So we're going to add the 10 minus the 2. So guess what? We're going to add the 10. 1, 0. Add the 10. But guess what? This minus 2 is not there. We have no beads, but we know. But we know. How do we know? Minus 2, remember the 5? Is equal to minus the 5 plus the 3. This is why we call it a two-step, because now we're taking this information and we got to substitute it into here. So minus the 5 plus the 3. My final answer is 13. That's what makes it different. What makes it different is the add-in. It's always about the add-in. How do you add it? When you know how to add your numbers, specific numbers, then you'll be able to understand what formulas you need to use. And then it can be scalable. Thank you, Skull. Thank you, Skull. Good game. I don't know what GG is. Skull, good game. Skog. Skog. Skg. Jeffers, did that make sense? Or do we remember this? So we're going to do another one. You lost me there with the minus 2, but I get it. I'm loving it. Yeah. See, that's what we call a two-step equation. Two-step equation is very common in algebra. And so now we're introducing a little bit of algebra into Abacus. And now you understand it's the gateway. Abacus is the gateway to more complex math. But this is the fundamentals. We can do it again with the 7. So we have 7 plus 7. Yeah, 7 plus 7. I add 7 on my abacus. I want to add another 7. I'm not going to memorize. I'm going to add another 7. What am I going to do? How do I add the 7? Plus the 7 is what? Plus the 10 minus 3. So I'm going to add the 10. Guess what? I cannot take away the 3. I cannot take away the 3. I only have these two to take away the 3. So what do? LMN, do you remember? How do I take away the 3? This is what I call the two-step. It's going to be rainbows. Christmas. This is what we call two-step. Do you remember how to take away the 3? We can utilize this 5. Remember, we're not going to have, thank you, Abby. Yes, we're going to minus the 5 plus the 2. What did we just do? We substituted this information into here. That is why we call it, yes, thank you, LMN. That's why we call it a two-step. Because we can't do it, so we got to do it again. We got to find another way to do it. Minus the 5 plus the 2. And thank you, Tonronkin. The answer is 14. Does that make sense, Abby? Right? Make sense? We're not going to memorize our doubles. We're going to understand the concepts, and then we can keep going. And then it becomes scalable. Thank you, Sam, for the rose. We can do another one. We can do another one. But see, once you understand that there's this fluidness, it becomes number. You become number flexible. We can do another one. What's another one? It was this one. We can 99 plus 1. That's easy, right? Can we do? Oh yeah, we can do 6 plus 8. We'll do that. Good one. That's a good one. Yeah, the two-step throws me off a bit, but I get down. Yes. Yeah, it takes a little bit of understanding. Jeffers, are you still around? So we have 6. So Abby knows the two-step. We want to add the 8. To add the 8 is what? Plus the 8 is equal to plus the 10 minus 2. Plus the 10 minus the 2. Can we take away the 2? No, we can't. What's another way to minus the 2? Abby knows. How do you minus the 2? We want to what? No. Minus the 5? No. Because 2? No, not 4. 2? What's the partner of 2? What's the pair? Yes, 3. Thank you, Erica. Minus the 5 plus the 3. Yes, thank you. That's what it is. Thank you, Raphael. Thank you, Abby. Right? So we're going to minus the 5, and then we're going to add the 3. So my final answer is 14. Yeah, here is something, here is the secret. Here's the secret. And I wrote it all out. Oh my gosh. Here we go. This is the framework that we're doing. Now, if you look, here is 7. Right? So we add 7. We want to add the 4. When we add the 4, can we do it? Yes or no? Can we add the 4? No, we cannot add the 4. Here. Can I add the 5? Yes or no? No, we cannot add the 5 because we're already using it. So what? We need to add the 10. Plus the 10 is minus the 6. Plus the 10 minus the 6. So my final answer is 11. It works the same way. It works the same way. So if I had this one, right? Oh, this one was what, 14? We'll do it again. We had 6, right? Where on the abacus do you read 14? Hey, Shane! Oh, I didn't. It was something else. This was something else. Mother, right? So let's do it again. So we have 6, right? I want to add the 8. Can I add the 8? Is there enough beads to add the 8? Yes or no? No. So then I go here, because there's no 5, right? I go here. Add the 8 is what? Plus the 10 minus the 2. So I'm going to plus the 10 minus the 2. So I plus the 10 minus the 2. Can I take away the 2? Can I take away the 2? Yes or no? No. Can I take away, oh, sorry, take away. Can I take away the 5? Yes or no? Can I take away the 5? Yes, I can take away the 5. Minus the 5 is minus the 2 is equal to minus the 5 plus the 3. Minus the 5 plus the 3. Minus the 5 plus the 3. And my answer is 14. So you follow this. This is the workflow. I'm trying to. This is as far as it goes. There you go. That's the workflow. Right? Every number follows this workflow. I need to memorize the formulas. Hey, Cody. Can't you just go 6 times? Can't you just count 6 times up from the number 8? You could. You could. It's up to you. But then, when the question gets big like this, do you want to start counting up? You could do that too. You could count up. That's up to you. Or you can count down. But I'm tired after 10. See, that's the thing, right? Like, that's the thing. Like, this looks really easy, but this is fundamental. It's like taking your jacket off. Take your jacket off, put your jacket on. This is what this means. You understand the fundamentals, then you'll become scalable. You start slow, and then you can move forward. If you skip steps, right? If you skip steps, then you just get lost. You can add either left to right or right to left. It is up to you. I think I'd be confused. I think it'd be more confusing. No, we've done this before. We did this before. We did this before. Oh, were you guys here for that? We did it before. So we have 1, 3, 5, 7, 7, 8. We did it before. Add the 2. Can you add the 2? Yes or no? Yes, add the 2. Can we add the 4? This is my first time. Yes, we can add the 4. How do we add the 4? How do we add the 4? Do you remember how to add the 4? How do we add the 4? Remember how to add the 4? Plus the 4. plus the 4 is what? Plus the 5 minus 1. Oh, you can't see that. Plus the 5 minus 1. Right here, plus the 4. Right? Plus the 5 minus the 1. Can we add the 3? Yes, we can add the 3. Can we add the 1? Yes, we add the 1. Can we add another 1? Yes, we can add another 1. What did I just do? This right here was our plus 5. So my final answer is 37,889. We want to do it again? We can do it again. Did that make sense? I don't remember. Oh, sorry. I apologize. No, that's my bad. Right? You can do it. We'll do it again. 1, 3, 5, 7, 8. Right? I thought it'd be more confusing. No, that's what I'm saying. You understand the fundamentals. Everything is gold. Everything is golden. Now it becomes scalable, right? Hi, Austin. Thanks for doing this for humans. Let's do it again. Can I add the 2? Can I add the 2? Where's my column isolator? Can I add the 2? Yes or no? Yes, I can add the 2. Not a problem. Can I add the 4? You know how to add the 4. I have 3 on my abacus. How do we add the 4? How do we add the 4? See, it's one number at a time. How do you add the 4? Tell me what the formula is to add the 4. Plus the 5 minus the 1. Can I add the 3? Yes, I add the 3. Yes, thank you, Element. Can I add the 1? I'm over here. 7, add the 1. This is 8. Oh, that's 8. This is 8. Add the 1. Yes. So what is my final answer? My final answer is 37,889. Easy. Doesn't matter now. It doesn't matter how big the numbers are because we know the fundamentals. We can do 3-digit. Here's my 3-digit. This is easy. There's no need to do friendly numbers, right? We have 283. We have 283. Question, can I add the 5?
Yes, we can.
Yes, I can add my 5. All I got to do is add the 5. Can I add the 1? Yes, I'll add the 1. Can I add another 1? Yes, I can add another 1. That's it. Because we see the numbers, it tells us whether or not we can do it. If not, then we have to use our formulas. Okay, somebody asked about going left to right, right to left. It doesn't matter which way you go. It just matters on keeping track of the numbers. Can we do one with formulas? See? Now you're seeing it, right? So we do double digit. Here's another double digit, but it's an easier formula. Right? We have 20, we have 6. Doesn't matter if you go left to right, right to left. It doesn't matter. You just need to track your numbers. I go left to right because I think it's easier because I've been doing it from left to right. But you can go right to left. Why? Because mainstream goes right to left. You can. It's up to you. Austin, you just add them all down the line as they go through the same digit. Yes, exactly. So if we have 2, we want to add the 2. When we add the 3, you're right. When we add the 3, how do you add the 3? It doesn't matter which way you go. You just got to track your numbers. How do you add the 3 to this? We know this. What is our formula? Minus the 2 plus the 5. Exactly. So my final answer is 58. Thank you, Abby. Thank you, Element. And it's good, right? You could do it any which way. Plus the 5, minus the 2, or minus the 2 plus the 5. It doesn't matter. You get 5 either way. Make sense? You get 5 because of the 3. As long as you track it. But it's the same thing. So thank you, Austin. So when we're looking, right? We call it, in mainstream math, they call it cumulative property. In Abacus, we're kind of doing it, but not really. Because the definition itself says addition states. But in Abacus, we don't do that. In Abacus, we need we need to balance the equation. If you know how to add, you will know how to subtract. You need to balance the equation. So you can do the cumulative property, right? It doesn't matter as long as it's the same formula. You could do it again. You could do it again to this. Adding the 10 minus the 2, minus the 10, minus the 2 plus the 10. Right? I don't mean any disrespect, but how is this useful in the time of age of Hey, Ro. Okay, see you later, Abby. Ask the questions or explain things. Okay, so, Ro, usually I'm teaching children. So I don't know how old you are, but you don't let the kids go on you don't let the kids go to the computer. But then there's the other thing, right? Like, Ro, I don't know if you do jigsaw puzzles. What's the point of doing jigsaw puzzles? What's the point of reading a book? We have audio, right? Okay, LMN, thank you. Get some rest. Hopefully I'll see you. Yeah, I'll see you in my next live. And then Ro, I don't know if Ro's still here. Thank you so much. LMN, thank you so much. I'm hoping that it made sense. But you were getting it, right? So what's the other one? Why do we do Sudoku? Hi, user. I'm interested in learning. Oh, okay, cool. I don't know if Ro's still around. So, but why do we do Sudoku? Because it keeps our mind active. Why do we do word searches? Because it keeps our mind active. We do Abacus because it keeps our mind active. Thank you for teaching. I enjoyed this. Yeah, right? Especially so late at night. Okay, user. Let's do a little review. Thank you, Melinda. Right? It keeps our mind active. You could doom scroll, then keep on doom scrolling. Or you can stick around here and understand how to use the abacus. Keep doom scrolling. That's fine. I'm perfectly fine with that. You don't need to stick around. Thank you, everybody, for those that are sticking around. But please, keep your mind open.
Now open your mind to me, please. Open your mind.
And it just depends if I've got jokes. I'm glad I came across your live to learn something new. The Doom Abacus. Hey, Panda, welcome back. It's been a while. Yeah. Okay, sorry. User, I love popping in when I can. It's fun to learn. Who created this tool? Who created the tool? Mesopotamia, like before Christ. User, sorry. 1, 2, 3, 4. So all the beads that are touching this horizontal bar is considered counted. So we have 4. 1, 2, 3, 4. We can do it again. Let me do it again with some money because sometimes it's helpful when we see it. 1, 2, 1, 2, 3, 3, 4. That's 4, right? Then we have 5. Well, what's 5? 5 is like a nickel. 5 is like 5 cents. This is 5. That's what 5 is. What are we going to do? We have 5 and then 6. That's what 6 is. And then 7, we have 7. And then 8, we have 8. And then 9, we have 9. Hey, Panda, let me put a pin in that. If not, I'll put a post up on that. Divided by 4. Right? I am too far in. Yeah, you are. All right. User, did that make sense? So then what's after 9? After 9 is 10. That's what 10 looks like. How do I know? 1, 0, 0, 1, 1, 0. Yeah, Melinda's been waiting as well. Melinda's with you. Why do you start there? Because I have this indicator. Thank you so much for asking. I have this indicator, if you notice, there's actually 2. Because there's 2, right? I can choose any one like a Pokemon. I could choose...
Pokemon, I choose you!
If I choose this one, then I'm going to be like this. And I'll have my 1s, my 10s, my 100s. And it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 10. So 10, 20, 30, 40. But then we have no more room for our hundreds. Thank you, baby daddy, for sharing my live. Your baby daddy. My baby daddy. That's hilarious. Thank you so much for sharing the live. Does that make sense? Okay. So instead, I like to choose this one.
Okay, Charizard, I choose you!
So I'm over here. So I have my 1, 2, 3, 4. I have my 10s. I'm sorry, 1s, 10s, 100s, 1000s, 10,000s. So yeah, So I go 1, 2, 3, 4, and then I have 5, 6, 7, 5, 6, 7, 5, 6, 7. 5 plus 2 is 7. 5 plus 3 is 8. 5 plus 4 is 9. 9 and then 10. 10 is a 1 and a 0. 1 and a 0. A 0. So if you're ever interested, I do have, oh, I don't know if you can see it. I might have a link in the bottom to say service. If you're looking for a reference, I do have reference sheets, and it just explains how to read the abacus. There's a link. It says Service Plus. You can put in Abacus, DM me Abacus, and I'll send you a link to sign up for a reference sheet. This book is available on my TikTok shop. I do have a lot of Abacus books but they're very specific to Abacus. And all they do is they do adding, subtracting, and we're going to go into multiplication and division. I always thought Abacus counted by doubles. No, Christopher. Yeah, 1, 2, 4, 8, 8, 16. Huh, that's interesting. No, I don't see that. I don't see how I could see it, but no, it doesn't go by doubles. Yeah, thank you for showing one's tens place. That makes sense to me. Oh, good. Oh, good. Yeah, not a problem. And so, yeah, let me know any other questions. And so that's what we were doing is we were adding and subtracting. We were adding how to make a 5 and how to make a 10. And that was the thing. So understanding how to make a 5, right, to utilize the 5, this is what this is. And so when we're adding, we want to know if we want to add. We have 1 plus 1 is 2, right? 2 plus 2 is 4. But then there's not enough beads to add the 4 if I want to add another 4. And then what? Each line stands for a double. Each column is a double? No, because this is 1, this is 11, this is 111, this is 1,111, and then this is 11,111. I'm sorry, 11,111. That's what that looks like. So if I did this, this would be 2. So if I did this, this would be 2, 2, 2, 2, 2. And then 3, 3, 3, 3, 3, 3, 3, 4, 4, 4, 4, 4, 4, 4. And then we have 5. These are all 5s. 5, 5, 5, 5, 5, 5, 5, 6, right? 5 and 6. So we do 6, 6, 6, 6, 6, 6, 7, 7, 7, 7, 7, 7, 7, 7, 8, 8, 8, 8, 8, 8, 8, 9, 9, 9, 9, 9, 9, 9. That's it. Yes, this is much easier. Yeah, it is a little bit easier than counting by doubles. Yeah. So, and then when we're looking at it, we want to make sure we're happy when we do abacus. And no matter how big and burly your hands are, you should be able to move the abacus with your tips of your fingers, right? In the edges of your fingers. So when we're happy, right? That's what we're doing. So, you don't notice, but I'm only using the edges of the beads. And then what's going to happen is we don't want to be aggressive. The reason why is because the answers will become wrong. Why? Because the beads are very easy to move. So do not flick, right? Be gentle. Thank you.
And flick. Oh, flick too hard, damn it!
You want to be gentle, right? You want to be intentional and you want to be gentle. So if I have 5 and I want to add the 3, I'm adding 3 like that. That's what I'm doing. I'm not just going to do that, right? Because now my answers are all wrong. So what we want to do is we want to be gentle, but we want to go in with intention. And we want to be happy, right? And use your left hand to stabilize because... And use your left hand to stabilize the abacus. The reason why is because if you bump it, you're going to get the wrong answer because it's very easy to move. And that's the way the abacus are. It doesn't matter which one you're using. If you have this one, which is a 13 column one, because size matters. Because size matters, it works exactly the same. This just happens to be 13 columns. Because it's 13 columns, it just means I can have more digits. That's it. Because I have more digits, I can count to trillions. So if I started here, be my ones, my thousands, my millions, my billions, my trillions. That's it. Thank you, Melinda. Yes, be gentle. Thank you, Kizzle. Don't flick. Be gentle. Yes. right? And it works exactly the same. So these are also available in my TikTok shop as well. What are we doing? This one. Here we go. Yep. Cool. Anybody have any other questions? How long have I been on? I don't know anymore. Okay, off to bed. Yes, thank you. Me too. I'm going to sign off as well. But if there's any other questions, let me know. But I will, you know what, Panda, we want to do this now? Panda, are you still around? Uh-oh, 90 user. What? How are we doing? I think Panda left. Melinda, are you still around? Are we doing this? Do you want to do this? We can do this. Okay, this will be the last one. Oh, thank you, Christopher. I appreciate that. Okay, let's do that one. So the question is 4 divided by... Oh, I can... No, I can't. I have... Okay. So what? 4 divided by 92. Okay, we know how to do this. We know how to do this. This is easy. So we have our chart, right? It's been a while since we did this. We're going to lose a lot of people, which is fine. But we're going to lose. That's fine. Cuz this is the end. After this I'm going to sign off after this. So what we're going to do is we're going to understand where we're starting, right? And what do we do is we take away our numbers. So we have 2 digits here, we have 1 digit here. 2 take away 1 is 1. So we're going to come over here. Why? Just because I want to be able to put my dividend on my abacus. So my answer is going to be here. My quotient, is going to be here. So what am I going to do? I'm going to put 90. I'm going to put 2. Remember what we're going to do is we got to compare. So we have to compare our dividend and our divisor. Because we compare our dividend on our divisor, here is our dividend and our divisor. A divisor is 4 and our dividend is 9. Who is bigger, Melinda? Melinda, it says this one, right? Our dividend is bigger. So we know that we're going to skip 1. Thank you. We're going to skip 1. That's just one of the things that we got to do. We got to skip it. So we got to skip 1, and we know what it is. We know 4 times what is equal to 9 or less. We know 4 times 2 is equal to 8. So we add 2 here, and we take away 8. Take away 1, take away 5. Take away 5, take away 3. So now we're left with 2 and a 0. 1, right? Our final number is 1. So 4 is our dividend, and 1 is our divisor. No, not divisor, dividend. Divisor is 4, dividend is 1. We compare, yes, divisor is bigger. So we know we have 4 times what is equal to 1. That doesn't make sense. We need the second digit. This is the second digit. We need the second digit to be this. So that means what? 4 times 3 is equal to 12. I don't know what you're talking about. That's fine. We're talking about the abacus and we're doing division. 23. Oh yeah, thank you. So yes, our answer is 23. 23. Yeah, it's really crazy. So I was able to do my automation, but I can't find it right now. I'll have to show you later. Division. Yeah, this is division. We're doing long division. So abacus does long division. Thank you, Melinda. Yeah. Let me see. Do you want to do another one? Let me see if I can find it. Okay. Last one. But I'm really excited for this. Here. Okay, let's do this one. We'll do one more. Oh no, I think it broke it. Okay, let's see if I can do this one. Let's see how tired I am. 29 divided by 1972. Let's see how tired I am. Yours didn't drop. Last one? Yeah. Hey, Riley! We're doing division. Hey, Yari! Haha, you guys are so funny. Can you slow down when you move the beats? Yeah, I'll slow down. Am I a teacher? I am now. All right. So, okay. Riley, how are you doing? Okay. So what are we going to do? I hope I have enough room. I need this one. That's good. And the job is good? Yeah? Okay. So we're going to count 1, 2, 3, 4, 1, 2. 4 take away 2 is 2. So we got to count 1, 2. 1, 2. So we're over here. Right? So 1, 2. Okay, wait. So I'm here. This is 2. I have to put in my dividend. 1, 9, 7, 2. This one is going to be an overquotient. Can you explain exponential function for my exam tomorrow? I know. Nope, sorry. That's above my pay grade. I only know division on the abacus. So when we're looking at, right, we're looking at the 1 and the 2. The question is what? I'm going to compare. When I have, my town has a community theater. Oh, yeah. I decided because why not? Why not? That's good. That's really good. Good luck. That's exciting. Yeah, I should always try something different. Dividend is 2. I'm sorry. Divisor is 2. Dividend is 1. So what am I going to do? My divisor is bigger. So I know what times 2 is equal to 1. But again, what? I need to have the second one because this doesn't make sense, right? I need to fill it out. So I got to put in my 9. So 9 times 2 is equal to 18. Add my 9 and then take away 1, take away 8. Guess what? This is too much. This is too much. So what do? I have to take one, I have to go back a step, right? So what I did is I kind of guesstimated and I tried it out. Now I have to go back a step. So to go back a step, I need to take away the 1. So instead of doing 9 times 2, I actually had to do 8 times 2 is equal to 16. But now I have to add the 2, right? Because I took away too much, so I add the 2 back. So then my question is 9 times 8 is 72. Can't do it. Guess what? I got to go back a step. So it's 7 times 2 is equal to 14. To do that, what do? I have to take 1 from the answer, go back here, and I got to add the 2. So now the question is 7 times 9. 7 times 9 is what? 64. Can't do it yet. So guess what? I got to go back and go 2 times 6 times 2 is equal to 12. Now what do? Take away the 6, take away 1, and then come back and add that. So now I have 6 times 9. 6 times 9 is equal to 54. I add the 54. 6 times 3 is not. What? 63, not 64. I don't know where you're at. So we're going to take away the 5 and take away the 4. Take away 4 is what? Minus the 10? No. Take away 4 is what? Minus the 5 plus the 1. So we're going to compare again. Who's bigger? My dividend or my divisor? My dividend and my divisor is the same. So they got to do something. What are they going to do? We got to go to the next number. The 9 and the 3. 9 and 3. 9 is bigger. So what do? 2 times what is equal to 2? Actually, 2 digits, 23. Did that make sense? That doesn't make sense. I think I broke my brain. I think you said 64. 9 times... Whoa. 7 times 9. No, but we don't do 7 times 9. We did 7 times 2. Oh, maybe that's what it is. 64. Whoa. 56. 9 times 6. No, we're still good. 60. And then we got to do it again. But then we can't do this, right? So it's 9. 3 times 3. I'm sorry. Is equal to 2 times 9 is equal to 18. So I take away 1, take away 8. Take away 8. Take away 8 is what? Minus the 10 plus the 2. So then what can we do? Can we do 9 times 9? No, we can't do 9 times 9. So we got to take 1 from the answer, go back 2, add the 2, right? So we got to do 2 times 8, right, is equal to 16. So what are we going to do? Now we could take away 72. My brain just melted and I got here. Yeah, I think you need a rest. It seems tired. Yeah. Yeah, but that's the answer, 68. But see, the thing is right here is the over quotient, is the over, what we call is over quotient. So it's a larger quotient than we needed. So the funny thing is making sure that you go through the cycle until you get to the point where you can do it. But this one was a very good one. I just got to figure out, I got to figure out is like how many times to do it. That's what I got to figure out. All right. So, but yeah. Oh, I don't know if Jeffers is still here for that. But that would be one of the things. That would be one of the bigger questions. I think I got lost too. You know why it didn't matter if I said 63 or 64? Because my 6 and my 7, because of the ones. That's why. But we can do it again next time. So for those of you that just joined, thank you for sticking around. To look at the abacus, to read the abacus, we're going to count 1, 2, 3, 4, and then 5. That's how we do it. So after 5, we have 6, 7, 8, 9, and then we have 10. There's 10. I guess it takes time. It does take time. Don't forget, I've been doing abacus for 20 years, right? So I can go through and I understand what I'm doing, but I know I talk too fast. And I apologize that I talk too fast. We can do it again, but I think I've been on for 2 hours and I'm about to head out. Don't write it off normally. Yeah. So after 10, right? 1 and a 0. We have 11. So how do I know my numbers? Well, I know my numbers because every column has a place value. Yeah, I'm starting to wind down. Hey, Abby, I'm back. I'm about to, Insensible Scenario. Good night. Have a good night, Insensible. So we have our ones, our tens, our hundreds, our thousands, our 10,000s. And then what are we going to do? We can count to 100, right? 100. 100. Then we do this, where you do 555. This is 55. So we have 10, and we count by 20s. We can count by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90. And then we have 100. And what we're doing is just we're learning how to read the abacus. I went a little bit far off and did I did division. Yeah. But apparently I got more people because I was doing division. I hope you enjoy your rest. Love the channel record. Oh, thank you, Chris. Sorry. I apologize for the division. I don't do division too often, but when I do have some old timers, we want to do some division. We want to test out our information. We want to test out our brains. Thank you so much, Chris. I hope to see you next time. So yeah. So that's what we're doing on the abacus. And we're just reading the abacus. But yeah. Brand new here. Hello, Samuel. Hello, Sam. So we're doing, let's do another review and then we're going to sign off. Yeah? Hey, CompuBear, welcome back. I didn't see you there. Okay, so we're going to count one more time. We have 1, 2, 3, 4. Now when we're looking, right? Division. Division. Oh, yeah. Here. Melinda, take a picture of this one so you can try to figure out how to do it. Right? It's a good one. Yeah, the answer is what? 68. Oh, so this is 4. So when I look, I have pennies. 1, 2, 3, 4. That's what it looks like, right? 1, 2, 3, 4. And then what? We want to do 5. 5 is this. 5 is that. Done. Oh yeah, good luck. Let me know how you fare. I like this one because you had to do it a few times. 5 is that. 5 is this. So this nickel is worth 5, and then I can do 6. I can show you 6. I can do 7, and then I have 7. I have 8, and then I have 8. And then I have 9, and that's what 9 looks like, right? Then what's 10? 10, if you look, is 1 and a 0, just as how we write it, 1 and a 0. So our 1's in a 1's place. We can do 2 10s, 3 10s, 4 10s. Does that make sense? So what we're doing is we're just learning how to read the abacus. And when we're looking at it, we can do 45. And then we have 55 and 65, 75, 85, and then 95. Yeah. Anybody have any questions? How's it going? But woof. Okay. Yeah, that one is a good one. I think that's why it broke. How do you compute with this thing? Go to bed. Yawning is contagious. I know, right? Oh, how do you compute? I'm brand new to the abacus. Really, it's just if you have any beads. So you have 2, and you have another set for 2, you just do 2. That's all it is. If I want to do 2 and I want to add the 5, we're going to add the 5. That's what it is. So we have 5, I want to add 2. If I do this, right, I took it away. So what did I take away? I take away 8. To take away the 8 is minus the 5 minus 3. Take away 8. So I have 9, and I take away 8. There we go. Is the abacus the thing you're using? Yes, this is the abacus. This is what we call a soroban. A soroban is a type of abacus. It's a Japanese abacus. Yep. Thank you, everybody, for joining. But yeah, it is time. It is time. All right. Are there any other kinds? Yeah, there is a Chinese abacus. There is a Chinese abacus. There is an abacus that Fairy Mary uses from Tinkerbell. Can you do multiplication really quick? Hey, user 397. Yeah, okay. We can do a real quick one. There's a Chinese abacus, a Russian abacus. There is a Reckon-Reck, which is a Dutch abacus. And then there's another abacus that's 9 beads. And there's a Russian abacus. I think I said that already. Yeah. Busy. I'm glad I've been able to pop in. Yeah, thank you for so much for popping in. Almost. Let's do one more thing. And we'll do it. This is going to be easy. We'll do multiplication. Okay. So in multiplication, what we're going to do is it the same principle as this one? Yeah, it's the same one. So the Chinese abacus works roughly the same as the Japanese abacus. Okay. So what we're going to do is we're going to call it, what we do in abacus is we do distributive property. That's what we're doing. We're going to do distributive property. Distributive property is a common term for what? Algebra? Oh, maybe I should just rewrite it. I'm going to rewrite it. Okay. So we have 93 times that by 8. The first thing we're going to do is we're going to understand where we're going to put our answer. The reason why we're going to put our answer is because we're going to put it on our abacus, right? So we have 1, 2, 3. 1, 2, 3, right? So what we do is we need to do this 9 times 8. Now, if you notice we do 9 times 8 is what? 9 times 8 is 72. But on the abacus, we just need to do our multiplication fact. Multiplication fact is 72. Mainstream, new math, what is it? New math, what do we do? New math, they do 90 times 8. And then they tell you it's 720. Right? But in new math, we don't need to do this in abacus. Why? Because it keeps track of our information. 720. That's what it tells me. I don't need to write it out. I just need to know my multiplication fact. I don't know if your multiplication fact goes up to 90, but I know mine doesn't. Thank you, Melinda, for the 3 place. Right? So we're over here. We add 72. Now we're going to add 24. 8 times 3 is equal to 24. So do I have it? Yes. I can add my 2 and I add my 4. And that's it. So on the mainstream math, we do what? 3 times 8 is equal to 24. And then you have to add it. Thank you, Melinda. My answer is 744. And that's it. That's multiplication. Yeah. Awesome. Yeah, you can do multiplication, you can do division. But I am going to sign off. Thank you again for joining, and I hope to see you in my next live. Got it. Right, Angela? You inspire me to do this. Thank you. What kind of math is this? This is multiplication abacus. Whoa, that just bumped up. Thank you. Very interesting. Sleep well. Yeah, thank you. You too, Melinda. Sleep well. Thank you so much. I appreciate everybody joining. 51 people. Wow. 51 people watching me yawn. That's funny. All right. All right. Yes, I am going to head out. It's been a little bit. Thank you, everybody, for joining. Have a good night, and I will see you all in my next live. Thank you, Angela. Good night, eh? Good night. Good night, user 397. All right. Have a good night. Good night, Melinda. Sleep well. Thank you, Abby. Good night. Good night, Erica.